A proxy server is an intermediary computer that sits between you and the internet. It acts like a middleman, handling your requests and responses while providing additional features such as security, privacy, caching, and access control. Instead of connecting directly to websites, your request first goes to the proxy server, which then communicates with the target website on your behalf. There are four main types of proxy servers. Forward proxy acts on behalf of clients, hiding their identity and managing outbound requests from your network. Reverse proxy acts on behalf of servers, handling incoming requests and distributing load across multiple servers. Transparent proxy intercepts traffic without the client knowing, commonly used for caching and filtering. Anonymous proxy hides your client identity by masking your IP address, though it can still be detected as a proxy server. Proxy servers offer three key advantages. Enhanced security filters out malware, phishing threats, and unwanted content while providing encryption for sensitive data. Privacy protection hides your IP address and masks your user identity to prevent tracking and maintain anonymity online. Performance boost caches frequently accessed content locally, reduces bandwidth usage, and accelerates page load times significantly. The proxy server operates as a central point between three components. A client sends requests to the proxy instead of directly to the destination. A proxy server receives and processes these requests, then forwards them to the target server using its own IP address. A target server responds to the proxy, which then sends the response back to the client. Proxy servers have practical applications across four main areas. Web caching stores frequently accessed content locally to reduce bandwidth costs and accelerate content delivery to users. Content filtering blocks unwanted websites and malicious content, enforcing organizational policies for internet usage. Load balancing distributes incoming requests across multiple servers to prevent overload and improve system performance. Anonymity and privacy masks user IP addresses and browsing activity to maintain privacy and prevent online tracking. Forward proxy and reverse proxy serve different purposes. Forward proxy acts for clients or users, representing them to servers, masking user identity, and managing outbound traffic from your organization. Reverse proxy acts for servers or resources, representing servers to clients, handling load balancing, and shielding the actual server identity from the internet. The proxy request flow follows 4 steps. Step 1. Client request sends the request to the proxy instead of directly to the destination server. Step 2. Proxy analysis checks the request against policies and consults cache or authentication services. Step 3. Forward or cache returns cached content if it is valid, otherwise forwards the request to the target server. Step 4. Response handler receives the server response, may modify it, then returns it to the client. Proxy servers present 4 security risks that must be understood. Man-in-the-middle attacks occur when compromised proxies intercept and alter data without encryption, exposing sensitive information. Data logging exposure happens when unencrypted logs contain credentials, browsing history, or personal data that could be stolen. Misconfiguration issues arise from improper setup that can expose internal networks and create performance problems. Identity theft risk occurs when proxy operators and malicious actors access user data and IP addresses, leading to identity compromise. 3 security best practices protect proxy server implementations. Enable encryption by using SSL/TLS encryption for all proxy traffic to prevent interception and data breaches. Strong authentication implements multi-factor authentication and strict access controls to prevent unauthorized proxy usage. Monitor and log maintains detailed logs and monitors for unusual activity patterns to detect threats early in the process. Proxy servers are deployed across 4 real-world scenarios. Corporate networks use proxies to monitor employee internet usage, enforce security policies, and block unauthorized content access. Content delivery networks use proxies by internet service providers to cache popular content locally, reducing bandwidth costs and improving speed for end users. A PI gateway allows developers to deploy reverse proxies to manage API traffic, implement rate limiting, and protect backend services from direct exposure. Geo-blocking and access allows websites to use proxies to control content access by geography, enforce regional restrictions, and comply with local regulations.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.